Hi everyone. Today we are going to do a very important concept from permutations and combinations. Let me narrate the problem statement right away. In a toy shop, I shortlisted 10 items. In how many ways can I complete the purchase if I may even decide not to buy any? So friends, what's the idea behind this question type? Well, sometimes in a real life scenario, we have some objects out of which we can select any number. We don't have any particular number in mind. So how do we count our possible selections? This video deals in this concept through the toy shop scenario. And once we have learned how to count our options, we will practice 2 more questions on the theme. So let us begin. So friends, the logic works like this. I may have shortlisted 10 items, but at the time of actual purchase, there might be several other factors like budget or utility of these items that is playing on my mind. So I may select 0 toys, which means I don't purchase any of them. This can be done in 10C0 ways, which in turn is equal to 1. Or I may select any one toy out of the given 10 toys. This can be done in 10C1 ways. Or I may select any 2 toys out of 10. This can be done in 10C2 ways. Or I may select any 3 toys out of 10. This can be done in 10C3 ways. And so on. I can select any number of toys. So I can select 4 or 5 or 6 or 7 or 8 or 9 or maximum 10 toys. 10 is the upper limit because only 10 toys are available. 10 toys can be selected in 10C10 ways. Since our options are connected with the word or, remember in P&C, or means we add up our options. So let us place a plus sign in between all of these. The required number of ways will therefore be 10C0 plus 10C1 plus 10C2 plus 10C3 plus so on up till 10C10. This is a complete series of binomial coefficients, NCRs, for which n is equal to 10 and r ranges from 0 to 10. Does this mean we have to calculate these 10 or rather 11 numbers first and then add them up? Looks like a tough task, isn't it? So let me give you an alternate method of counting, the ultimate shortcut. Try to see that there are 2 selection possibilities for each object. For each item, there are 2 ways to select it. The decision whether or not to buy that object means there are 2 ways. Either you will buy or you will not buy. 2 ways. So purchasing this teddy bear, 2 ways. This basketball, 2 ways. This yo-yo, 2 ways, and so on. 2 ways possible for selection of each object. So to complete purchase, which means to select any number of items out of the first and second and third and fourth and fifth and so on and 10th items. Now remember, I also told you once that and means multiply. So our answer is 2 into 2 into 2 into 2. 2 multiplied 10 times, which is equal to 2 raised to the power of 10 ways. Now you must be thinking which method is better. Well, I would say you should know both. And needless to say, our answers tally for both methods. 10C0 plus 10C1 plus 10C2 plus 10C3 so on up till 10C10 is equal to 2 raised to the power of 10. In general, number of selections possible for n distinct items is NC0 plus NC1 plus NC2 plus so on up till NCN, which is equal to 2 raised to the power of n. You will understand the importance of this equation when the question requires you to buy a minimum number of items. What if we need to buy at least one item out of n distinct items? At least one means 1 or 2 or 3 or so on up till n. We need the sum from NC1 to NCN. We can simply shift NC0 to the right hand side of this equation for ease of calculations. NC0 we know is always equal to 1. So at least one item out of n can be bought in 2 raised to the power of n minus 1 ways. Similarly, let us suppose you need to buy minimum 3 items. So it's easier to think in terms of left-hand side. We need NC3 plus NC4 plus so on up till NCN. But this sum is easier to calculate if you know the right-hand side as well, which is 2 raised power of n. Now let's try out a practice question. There are 8 lamps in a hall. Each one of them can be switched on independently. Find the number of ways in which the hall can be illuminated. So friends, though each of the lamps may individually be switched on or kept switched off, which means 2 possibilities for each lamp, the hall will be illuminated if at least one of them is working, which means at least one lamp should be switched on. So the required number is 2 raised power of 8 minus 1. Question number 2 is the number of groups of 3 or more distinct numbers that can be chosen from 1, 2, 3, 4, 5, 6, 7 and 8 so that the groups always include 3 and 5 while 7 and 8 are never included together is ... and you have to type in the answer. Just for your information, this question was asked in CAT 2021. You may pause the video to try it out, and once you are done, let's discuss. So friends, this question is a little tricky because we can't use the formula directly. First of all, we need to see that there are 8 numbers, each of which could have been included or excluded from the group. Without any constraints, if we need to select, we can select each number in 2 ways. That makes 2 raised power of 8 possibilities. But the question says 3 and 5 should be necessarily included. For a moment, if we forget the constraint on numbers 7 and 8, the selection of number 3 can be done in only one way. The selection of number 5 also can be done in only one way. For the remaining 6 numbers, we can select them in 2 ways each. So 2 raised power of 6 total ways. But the group should have minimum 3 numbers. So that means we need at least one more number apart from 3 and 5. We have to subtract the possibility of rejecting all other 6 numbers. So we subtract 6C6, which is equal to 1 from 2 raised power of 6. Now let's think in terms of our second constraint that 7 and 8 are not included together. Thus, there are 3 cases possible. Case number 1 is when 7 is included but 8 is not. Case number 2 is when 8 is included but 7 is not. And case number 3 is when both 7 and 8 are excluded. These ovals represent the groups for each case. In case 1, we already have 3 numbers in the group. Remember, each of these numbers can be selected or rejected in the group in only one way. We have an open decision for the remaining 4 numbers, which are 1, 2, 4 and 6. We can select 0 or more out of these 4 numbers in 2 raised power of 4 ways. Case 2 is similar, 2 raised power of 4 ways. And case 3. Do keep in mind that as of now, we have only 2 numbers in the group, the numbers 3 and the number 5. Out of the remaining 4 numbers, we need to select at least one more, which can be done in 2 raised power of 4 minus 1 ways. So our answer is a summation of these 3 cases, 16 plus 16 plus 15, which is equal to 47. That's it. We type in 47 as our answer. So that brings us to an end of this video lesson. If you enjoyed watching this video and found it useful, do press the like button and subscribe our channel for related content. Here is a glimpse of other maths videos on our channel. Stay tuned and take care. Bye-bye.